All right, so I got two questions. The first one is calculate the volume of water needed to prepare 254 milliliters of a 0.32 mole per liter solution of KCl from 4.6 mole per liter KCl. All right, so something interesting to think about is this isn't asking for a volume of solution, it's saying volume of water. So let's draw out what this would be. So essentially, you want to make 254 milliliters or 0.254 liters, right, of a solution in some beaker. And you want that solution to contain a certain number of moles in order for it to be 0.32 mole per liter. Well, the first thing you always want to do, no matter what, is take liters and mole per liter and multiply them together. Anytime you have of a, you want to figure out the number of moles in there. So let's start by doing that. We've got 0.254 liters, because I just took milliliters, moved the decimal place over 3 times, of A. So I'm just going to multiply that by the 0.32 mole per liter. What this does is it tells us how many moles we need in total to go into here. So I'm going to take 0.254 times 0.32. I'm going to do it again just in case I messed up. And I get the same answer, 0.08128. I'm going to keep all those sig figs. Okay, so we need 0.8128 mole of KCl in here. But again, it's telling you the volume of water. It's not saying from this solution. So we've got this really strong solution over here. It's 4.6 mole per liter KCl. So this is stock. We just pretend we have an unlimited amount. This is the stock solution. And if we were to have a liter, it would have 4.6 mole in it, but it's got a lot of stuff in there. So usually we use like M1V1 equals M2V2 when we figure out how many liters of this stock solution we need to put in here, but that wasn't the question. The question was how many liters of water do we need to dilute it with? So what we need to do is figure out how much of this would contain that 0.8128 mole of solution. So what we have to do is say, okay, we need 0.8128 mole. And we know that in this solution, there's 4.6 mole per liter. So I'm going to divide the answer, I'm going to divide this 0.8128 by 4.6. And I get an answer of 0.01767 liters. In other words, 17.67 milliliters of this would go into here. So remember, we want 0.254. So if we start off by adding that little bit, there's 0.01767 liters. The question is, how much water do we need to dilute it with to get to the 0.254? Well, to figure that out, we take 0.254 minus 0.01767. So 0.254 minus what we had, and I get an answer of 0.23633. In other words, 236 milliliters. So you would have to take 236 milliliters of water and add it to the 17.7 milliliters of stuff, and that would be your answer that it's looking for. The next question I got, and probably should have separated this a little bit, sorry if this chromium stuff down here is confusing. The next question I got is essentially saying, hey, what color would a solution that's this be? And it says, hey, if chromium's got a 2+ charge, it's going to be blue. If it's got a 3+ charge, it'll be green. And if it's 6+, it'll be orange. So what you actually have to do is kind of look at the oxidation numbers here of each thing. Now, water is neutral. H2O is not going to have a charge. That's just kind of like a common thing. Although you could look at it in terms of oxidation numbers. Oxygen would have a -2, hydrogen would have a +1, and there's 2 of them, so it would be neutral. All right, so essentially what we're saying is the charge of chromium plus 2 waters plus 4 chlorines must add up to equal 2 positive. And we're going to do this in order to figure out the charge of chromium. We have no idea what its charge is. But we do know that it's not just any chlorine. This is an ionic compound, so this is chloride. Chlorine's in the 7th column, and therefore it has a -1 charge. So now when we go to solve it, we've got chromium, we don't know what it is, plus 2 times the charge of water, which is 0, plus 4 times -1, because again, chloride is -1, must equal 2 positive. All right, now we can kind of combine this. This is 0, and this is a -4, so we have chromium plus 0 plus -4 would be -4. -4 equals our +2, and then you add 4 to both sides. So if I add 4 here and I add 4 there, chromium is going to equal +6. In other words, chromium, the solution, will be orange. So hope that helps answer the student's question, and let me know if it doesn't.